Hello everyone. In this video I'm going to go over some of the trigonometrical equations that we've been working in class, some of the issues that you had in things like the latest quiz and the previous exam. And also I'm going to go ahead and do some extra exercises so we can show how to solve some more equations. So first than anything, in the previous quiz, we have this question where we have cosine of x equals 2 over 3, and we want to find out what the sine of x is, and some other values as well. So what you gotta remember is that they're giving us a specific value already for the cosine. We're not getting an angle. We're already given the value of the cosine, and they're telling cosine of the angle x is 2 over 3. So if we want to find out the exact value of sine of x, we want to consider that we are in the fourth quadrant. So the fourth quadrant is going to give us some information. Pretty much it says that the cosine has to be positive, but the sine has to be negative, right? Just by the positioning in the unit circle. Now, another way that you can think of this is the cosine is in a triangle is the adjacent over the hypotenuse. So if we have a triangle here on the fourth quadrant, we can see here this being the adjacent and this being the hypotenuse here for this triangle that's coming here. And so if we had that, then we can find this side by using the Pythagorean theorem. So pretty much doing the subtraction of hypotenuse minus the sine. So hypotenuse is square is 3 squared minus the sine square is 2, which is 2 squared. So 9 minus 4. Take the square root of that. Is going to give me square root of 5. Now, because we are in the fourth quadrant, that means that the sign is going to be negative. And the sine is the opposite, which is the square root of 5, over the hypotenuse, which is 3. So from this, we get that the sine of x is minus the square root of 5 over 3. Okay? So this is one way to get to that. The next question says, well, what is the sine of 2x? The first is that we need to first say, okay, so the sine of 2x is 2 sine of x cosine of x. And so once that we have that, then we can use the values that we already have. Notice that we don't have to plug anything. We just replace the values that we have. So we have the sine is minus the square root of 5 over 3, and we have the cosine is 2 over 3. So from that, we just replace in the formula what each of these pieces is. And we're going to obtain minus 4 square root of 5 over 9. Then last but not least, cosine of 2x. So we're going for cosine of 2x. And so there are many ways of finding that. We can use something in terms of the cosine or something in terms of the sine. So for this time, we can use the identity cosine of 2x equals 2 cosine squared minus 1. Why? Because cosine of x is the first thing that they give us. So if we put that in terms of that easy's value, then we don't have to do much. We just plug 2 over 3 square. And coming from the identity 2 cosine squared minus 1, the setup ends up being 2 times 2 over 3 square minus 1. And then this is 2 times 4 over 9 minus 1, or 8 over 9 minus 1. And 1 can be seen as 9 over 9. So this is just going to be 8 over 9 minus 9 over 9, so minus 1 over 9. Now finally, let's go to the equation. We want to determine all the possible solutions of sine of 2x equals sine of x. And here we're replaced by the formula. And so this is 2 sine of x equals to sine of x. Notice that if we cancel out the sine of x, we're going to miss everything that the sine of x can give to that equation. So we should not do that. The way that we should approach this is we move the sign to the other side, and then we need to factor. Then why can we factor? Well, because sine is a common term, and so we're going to get two factors here, sine of x and 2 cosine of x minus 1. And that equation is going to be equal 0. Now remember that when we have a product of two things being equal 0, then that means that each of them must be 0. So we have sine of x is equal 0, which in the 0 to 2 pi interval happens in three possible places. 0 to pi, 0, pi, and 2 pi. Okay. Sometimes we don't include the 2 pi, but in this case we're including it, so we have to put it there. Now the other equation is 2 cosine of x minus 1 equals 0, but that we can translate as 2 cosine of x equals 1/2. And that's going to have two different values. The first is when x is pi over 3, then we can get 1/2. If you actually plug this in your calculator and you get x is equals cosine to the minus 1 of 1/2, you're probably going to get pi over 3. Okay? But this is just one of the solutions. And remember, cosine is going to be on positive in two different quadrants. It's going to be in the first and in the fourth quadrant is where it's going to be positive. So that means that we're going to have pi over 3 as the first angle in the first quadrant. But if we're going to get an angle in the fourth quadrant, then that means that we got to do 2 pi minus pi over 3. And so that will be 5 pi over 3. And that's how we get this particular set of solutions. All right, so now as a brief reminder of the things that you need when you're solving trigonometric equations is all the information that we had on the unit circle. So, and this is not precisely a very good circle, but let's assume that it is. When we have here x and y axis, remember that the unit circle gave us this notion that x was cosine of certain angle theta and y was sine of theta. And so in general, I can think of this as a way to think about how the signs on the quadrants are going to be. So because we have that x on the first quadrant is positive and y on the first quadrant is positive, then that also means that cosine and sine in these quadrants are positive. If I'm assuming that I have, let's say, here an angle theta, and then these coordinates are over here from this point are being defined by x equals cosine of theta, y sine of theta. So given that we have this situation here, so instead of writing x and y, now what I'm going to do is just write cosine and sine. And so I'm going to go ahead and say, well, over here, if the angle is in the first quadrant, then both cosine and sine of theta are positive. If the angle is in the second quadrant, then, and what do I mean by the second quadrant? So again, is I have an angle like this. I'm looking for this angle, likely, or working with this reference angle here. And so in this scenario, I'm going to have that the cosine is negative, of course, because I'm on this side where the negative x are, but the sine is still positive. And so, of course, at this point, you can guess it. Here we have that the cosine is still negative in the third quadrant, but the sine is positive. This is quadrant 3, quadrant 2, quadrant 1, and quadrant 4. And so, and let me use quadrant 4 here. And so here cosine is positive because we are on the positive numbers in x, and sine is negative because we are on the y negatives. Okay. So it is important to remember that, because that's going to be important for the solution of an equation. If they tell me, let's assume the sine of theta is equals 1/2, then that's giving me a lot of information. This is telling me, hey, the sign is positive. What is the sign? The sign was associated with the y coordinate. So what we're looking for is essentially where this height is 1/2. So that means that I get two solutions. I get one solution on the first quadrant. I get one solution on the second quadrant. If I get the opposite, if I get sine of theta is minus a square root of 2/2 for some reason, then that tells me that I'm looking for negative values. And so I'm looking for a stuff over here, down here. So my angle is in the third and fourth quadrant, okay? And with cosine is the same thing. So with cosine, if cosine of theta is 1/2, then remember cosine is x. So it means that I'm talking about this, positive x. And my angle is going to be in the first and in the fourth quadrant. And I'm talking about the angle that I can get, of course, by joining that height from here to here and from here to here. Okay. And cosine of theta equals minus 1/2, then it means that you are on the negatives. And your angles are this one here on the second quadrant and in the third quadrant. And so here's where it comes all the discussion about reference angle that we had before. And so if the reference angle is in the first quadrant, and then it's theta, and that's it. If the reference angle is in the second quadrant, then to find that reference angle over here, to find this little angle here, what I gotta do is pi minus the reference angle theta that I use, and that mostly get from the calculator. If it's in the third quadrant, then the reference angle or the angle is going to be defined by the reference angle theta plus pi. So pi plus theta. And of course, if it's in the fourth quadrant, then I gotta do 2 pi and subtract the reference angle to obtain the angle that I'm trying to get. So hopefully this is a brief reminder of the stuff that we can get from the unit circle. Now, in terms of equations, equations will always give you two, for the most part, equations or trig equations will provide almost always more than one solution. So, for example, cosine and sine will only have one solution. Let me just get rid of this. Okay, maybe I can use this one. Yeah. Okay. Now I just need a frame of reference. Let's see if I can fit it out. Okay. So remember that cosine is the x, right? So cosine of x equals 1 has only one solution. It happens when x is equal 0. At least between 0, of course. Let me do theta instead. Between 0 and let's not include 2 pi. Because it's the same as turning around, right? So it only happens once here. If it includes 2 pi, then 2 pi works, but otherwise it will not happen. So this is the only point where the cosine has only one solution. Also, well, of course, if cosine of theta is -1, then theta is equals pi, and this is the other scenario. And for sine of theta is equals 1, that implies that theta is pi over 2, and sine of theta is equals -1. That implies that theta is 3 pi over 2. So only in this point and in this point is where the sine is just going to have one solution. Then after that, if I get something else, let's say sine of theta equals 1/2, then that's going to have two solutions. Okay? So notice that sine of theta equals 1/2 should be around here. And so that's going to give me two possible answers. So it's going to be this one here, which is going to give me this angle. And so that angle is going to be my initial reference angle, which is going to be 30 degrees, or also pi over 6, depending on if you're using radians or not. Then notice that my second angle is in the second quadrant. So my second solution is going to be pi minus pi over 6, which is 6 pi over 6, so this is 5 pi over 6. Or theta 2 is 180 minus 30, so pretty much 150 degrees. Okay? So I'm always getting at least two solutions, and this is for the simple equations. Now, depending on what happens, you might get more complex type of equations. So now I'm going to jump in some of those more complex equations. Now let's actually go ahead and do some equations. So first, I'm going to start with one where you might need to do factorization. So we have the equation sine of x minus cosine of x plus cosine of x minus 1 equals 0. So as you can see, this is a very convoluted equation, but as well, you do have a lot of things that they have common factors. So for example, this term and this term, they have a common factor sine, or you can also think that they have a common factor cosine, but let's go ahead and factor sine over here. And so if you factor sine, you notice that what is going to be left in here is cosine of x, because I just factored sine of x from this one, and since I'm factoring this sine of x, then I'm going to have 1. How can you know if this factorization is correct? Well, because when you multiply back sine of x by cosine of x and sine of x by minus 1, then you're going to get back this term. Now notice that I did factor that sine of x, and when I do that, I get a cosine of x minus 1. But notice that in here, I also have another cosine of x minus 1. So potentially, now this cosine of x minus 1 expression is a common factor. And I can do cosine of x minus 1, common factor of sine of x, because this sine of x is left, plus 1. Since this whole cosine of x minus 1 is going to be factored out, and the only thing left is going to be 1. Again, if you want to double check that this is fine, then you multiply back cosine of x minus 1 by sine of x and cosine of x minus 1 by 1. Now, this is a couple things multiply equals to 0. And remember that the zero product rule says that if a times b is equal 0, then a is equal 0 or b is equal 0. Okay? So the meaning of that is that cosine of x minus 1 is going to be equal 0, or sine of x is equals to sine of x minus 1 is going to be equal 0. So this means that now we have the equation cosine of x equals 1 or sine of x equals 1. Very easily we can see that cosine of x is equals 1, and let's assume by the sake of just simplifying this, that this is going to be between 0 and 2 pi. And so cosine of x being 1, only going to happen at x equals 0. And sine of x equals 1 is only going to happen at x equals pi half. So in this way, we just simplify the values that we can get. And so this is the end of the equation. Okay. So now let's go ahead and do another example. In this example, we were mostly doing factorization. Sometimes that factorization can come into play with more algebra. So another example here will be what happened if I have the equation 2 minus cosine square of x minus 2 sine of x equals 0. With this more complex equation, what happens is that you want to put everything in terms of the same trigonometric variable. Notice that there's nothing to factor. There's not a common factor that is easy, and there's no way to cancel anything. So the most easiest thing that I can do is transform this cosine square, because remember, cosine square is just 1 minus cosine. 1 minus cosine square of x is sine square of x, right? So I can either transform this by doing 1 minus sine square. And so now everything is going to be in terms of sine. You got to be careful though that if you have a parenthesis and you have a minus in front, you multiply everything by that minus. So for example, here is 2 minus 1 plus sine square minus 2 sine of x. Now I get this 2 minus 1, and so this is going to be 1. So essentially I can rearrange this as sine square minus 2 sine of x plus 1. And so now this is looking familiar, right? Notice that if you have a squared minus 2a plus 1, that can actually be factored as a minus 1 square. This is a binomial square. So the only difference here is that this a in this case is sine of x. And so if I can factor this expression into this, then in this scenario I can factor this into this. This becomes sine of x minus 1 squared equals 0. And then, of course, because this is a square equals 0, I can take the square root on both sides, and I get sine of x minus 1 equals 0. And so this means the sine of x is equals 1, and then x will be pi half will be the solution. Of course, I'm coming up because I know this from the unit circle, but remember that you can also be doing x is sine to the minus 1 of 1. And remember, this is one of the special points. Sine of x is going to be 1 when only x is equals pi half. So that was a very special case. Alright, so now let's move to one final example, one final complex example. So that was all of factorization via algebra. So you can do factorizations in that way as well. But now let's try something where we have to use the double angle identities. So now let's use 6 sine of 2t plus 9 sine of t. So again, this is similar to the one from the quiz. Notice that sine of 2t can be transformed to 2 sine of t cosine of t plus 9 sine of t. Here, the common factor, of course, is going to be the sine, since this is what is common here and here. This is going to be 12 sine of t cosine of t plus 9 sine of t. Okay. So I can factor the sine because it's common, and this is sine of t times 12 cosine, which is what is left from once I factor the sine, plus 9. Since here, once I factor the sine, that's what is out. Again, if you want to verify that this is fine, multiply back, distributing, and you should arrive to the same place. Now, we have a product of two things equals to 0, so this is going to give me two equations to solve. Sine of t equals 0, or 12 cosine of t plus 9 equals 0. So sine of t equals 0, and again, let's assume that t here moves between 0 and 2 pi. 2 pi open, so we don't have to include it. So t here can be 0 or pi for sine of t. And this equation here becomes 2 cosine of t equals minus 9, or cosine of t equals minus 9 over 12. And if we simplify minus 9 over 12, this is like minus 3 over 4. And this is like minus 0.75. Now, in here, especially when you have a number like this, inevitably you're going to be using the inverse function. So t is cosine to the minus 1 of minus 0.75. And if you put that in the calculator, then you're going to get about 2.49, which is less than pi, right? And so let's recall again that this is cosine. So if we are in the unit circle, cosine is corresponding to x. So this is an x value. Oh, but it is not a positive one. It's a negative one, right? So we are here. Since it's minus 0.75. And so minus 0.75 is telling me I'm going to have one angle here on the second quadrant, which I'm getting right here, 2.419. Remember that pi is when we got here, and pi is 3.14. So this makes sense. And so to get the other one, that angle is going to be here. Okay. And you probably need to get the reference angle here, which you can get it from directly from here, from subtracting pi minus 2.19. So you do like 3.14 minus 2.41. That will give you your reference angle, and then you can get the second one. The second one that is going to be here. And that's going to be 3.864. Okay. And again, if you want to get the reference angle, what we're getting here, this 2.49 is this angle here, but you might want to get this reference angle here, so you can add it later to 3.14 and get the second angle, that is this one. So remember that the only thing that you're getting to get the reference angle theta is 2.49. Backwards, sorry. You're doing 3.14, 15 minus 2.419. And so this will give you your reference angle. And then you add for T2, that's going to be pi plus whatever your theta that you found here is. And that's going to give you the angle here on the third quadrant. Okay? And so these are a couple of examples of equations, of solving equations, especially in terms of sine and cosine. So please keep practicing this, and let me know if you have any questions. Try to practice some more with the different practices that we have in Lumen.